9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff. Falcon 9 still to towers.
Live footage of Course I Still Love You, our drone ship, waiting for there's the engine. Slow it down, lights are deployed.
All right, thank you, Kirk. Now to Elon Musk, our SpaceX CEO and lead designer.
Thanks. Well, it's great to be here, and of course, we love doing a good job for NASA. So, thank you for allowing us to deliver the cargo. Yeah, I think the mice are doing well. That's what I heard.
I'm not sure they're happy though.
I think they might be a bit confused.
Yes.
So it's probably not on their evolutionary path to be in zero G, but yeah, there's a bunch of astronauts on board. So the thing that was a little different about this mission on the rocket side was, of course, the rocket landed instead of putting a hole in the ship, or tipping over. So we're really excited about that, and the reason that's really important is about half of our missions will need to land out to sea. So any missions that are going to, particularly to geostationary orbit or to escape velocity, anything beyond Earth is likely to need to land on the ship. And I thought it'd be worth just emphasizing that the reason for that is something that I think it would be good for the press to educate the public about, which is the difference between space and velocity, space and orbit. Like arguably, the space station should be called the orbit station, because it's actually zooming around the Earth at 17,500 miles an hour, and it crosses the Atlantic in I think about 20 minutes or so. It's pretty speedy, and that's for example why there's such a short launch window, is because the rocket's got to get into orbit and kind of match the orbit with the space station, and it's moving so quickly that orbital window is only open for a few seconds. So, although a rocket looks like it's going up because it starts off vertical, actually it's going to very quickly turn and go sideways and go horizontal, and it's going to match that space station velocity of roughly 17,000 miles an hour. So basically, the rocket at stage separation is zooming out to speed zooming out to sea at an incredible velocity, and it doesn't have enough propellant to come back to basically zero out that velocity, boost back in the other direction, and then land. So in order to achieve effective reusability, if you want missions to go to high orbit or to escape velocity, you really need the ocean landing. I just want to make sure that was explained, and we can, in the Q&A, we can go maybe into a little more depth on that. But I think as things make progress, I think it is. I think it would be good for the public to know a bit about orbital dynamics, because it is a little counterintuitive. So anyway.
Thank you, Elon. And now to Hans Koenigsmann, our Vice President for Flight Reliability at SpaceX.
Yeah, I just can fill in a little bit on the Dragon side. I talked to Mission Control on the way up. All thrusters have been fired, so we know Dragon's healthy. It's a good spacecraft. Everything's working. Our flight computers are running. Comm is working. Communication is working. The next thing that's going to happen is the opening of the GNC door, which then will activate Star Tracker. That is going to happen in about 2 hours and 15 minutes. And then the first orbital adjustment burn is going to happen in tomorrow morning. And docking with the space station then is currently planned for Sunday morning. I think it's 6 o'clock, early in the morning at Eastern time. So everything is going well. It's an awesome day. I think the team, both on SpaceX side, on NASA side, and also on the 45th side, worked awesome together, and we did a great launch.
Thank you, Hans. And we'll take questions now. Please give your name and affiliation when the microphone comes to you. Let's start right here. It's with James here.
Sorry. Sure. Thanks so much. James Dean, Florida Today. Elon, do you think this booster, if it checks out okay, will be the first to refly? How soon could that be?
Yeah, that's a good question. I think that that's likely. So the plan is to bring this booster back. Should arrive in port on Sunday, and then we're going to do a series of test fires. We're hoping to do that at the Cape rather than transport it to Texas and then bring it back. So our thought is to basically fire it 10 times in a row on the ground, and if things look good at that point, we feel it's sort of qualified for reuse in launch, and we're hoping to relaunch on an orbital mission probably around May or June, so it's pretty soon. Let's say June. I'm trying to recalibrate my timing expectations.
Just clarify that you could relaunch this booster within a few months.
Yeah. Well, I mean, in the future, hopefully, we'll be able to relaunch them within a few weeks.
Irene?
Thanks. Irene Klotz with Reuters. Congratulations, first of all. And with this, would that be a test flight, or would you hope to have a customer for that? And also, this has been kind of a long time coming for you. How do you feel about this, and were you surprised to actually see it stick the landing?
Yeah. Actually, we were just talking yesterday. Went around the table on odds for success, and the consensus was about 2 to 1. So we thought it was more likely than not that this mission would work, but still probably 1/3 chance of failure. But we'd eliminated the reasons, the prior reasons. So we were confident that if it did fail, it would fail for a new reason. So as it turns out, there's a lot of reasons for rockets to fail. But this is a beautiful day, and I think the circumstances were good. It's still quite tricky to land on a ship, and if you on the video, I mean, the ship looks quite small relative to the rocket, so it's quite a tiny target. It's really trying to land on a postage stamp there, and it's moving, sort of translating and rotating. It's sort of like a carrier landing versus a land landing. It's a tinier spot, and it's moving.
The use of the reflight, would that be an actual paying customer on it, or would you do that just as an experiment to relaunch it?
We think it'll be a paying customer, but that's we got to have some discussions. So, yeah.
All right, let's go right here.
So, Elon, having achieved this this milestone here, what does that mean for the future of SpaceX and for the future of spaceflight?
Yeah, I think this is a really good milestone for the future of spaceflight. I think it's another step towards the stars. In order for us to really open up access to space, we've got to achieve full and rapid reusability. And being able to do that for the primary rocket booster is I think, going to be a huge impact on cost. Now, it'll still take us a few years to make that smooth and make it efficient, but I think it's proven that it can work. And there probably will be some failures in the future, but we will iron those out and get it to the point where it's a routine. It's routine to bring it back, and where the only changes to the rocket are, maybe to hose it down, or clean, give it a wash and add the propellant and fly again. That's the key. Full and rapid reusability is fundamental. Yeah.
Bill?
Oh, well, Marcia was ahead of me. I'll let
Oh.
Marcia go in front of me.
Okay, Marcia, go ahead.
Marcia Dunn, Associated Press for Mr. Musk. Where do you expect the stage that landed in December on land, where's that going to end up? Is that going to be on display at your headquarters
Yeah,
ultimately?
soon, hopefully.
Hopefully? Is
Yeah.
that the plan?
We just got, our headquarters are close to or adjacent to the Hawthorne Airport, so we needed FAA permission, because it would be like the highest object for quite a distance around the airport, but we just, I believe, got that permission. So we're planning on putting the rocket that landed back at the Cape in front of the SpaceX headquarters in Hawthorne, hopefully in the next few months.
Oh, okay, thank
Yeah.
you. And could you tell, what was the velocity and the altitude for this booster? What's the highest altitude it reached in its peak speed before it started coming back?
So actually, I don't actually know.
200 usually.
Yeah, for LEO missions, the peak altitude is usually not super high. Like it's would have been something around a couple hundred kilometers, and the velocity also is not as high as it would have been on the last mission. The highest velocity missions that we see are the geostationary missions. So for example, for this mission, actually we could have brought it back to land, but we wanted to do a ship landing where we had lots of margin. So it would have been a low margin return to land or a high margin ship landing, and so this, I think, really helped us show that the ship landing could work. But in terms of the maximum sort of transfer velocity, which is this is really the key figure of merit for the boost stage. The maximum transfer velocity is we think we'll get up to about 9,000, maybe 10,000 kilometers per hour, and that's transferring an upper stage load, upstage with payload plus fairing. You're talking about 120 tons or thereabouts. So it's 120 tons to upwards of 10,000 kilometers an hour. So it's sort of quite a javelin throw.
Bill?
Yeah, Bill Harwood, CBS News. Two very quick questions. One is, I realize it was a fairly calm sea today, but those of us not used to looking at barges in the ocean, looked like it was rocking pretty good. What is, just out of curiosity, the maximum tilt the rocket could stand and stay vertical, number one? And two, can you talk a little bit about increasing your launch pace? You guys have a really busy manifest. You're starting to ramp things up here, and do you need more people? Can you do it with the crew you currently have here and at Vandenberg? Just generally about the pace. Thanks.
Sure. Well, first of all, I'd say it's a ship. It used to be a barge, but when we added engines and control systems and everything, so now I think it's sort of fair to call it a ship. It has 4 engines, but today the pitch and roll was about 2 to 3 degrees, so it was actually not too bad. In terms of maximum, well, probably, I'd say we could do double that easily, and maybe triple. So maybe it's 8 or 9 degrees, but that's probably about the limit. But that would be really intense seas. And you also see some translation where it's going up and down, so it's both rotating and translating. So it's tricky, just like a carrier landing. But it's, and both are going to absolute position. So the ship is holding to absolute GPS position with a relative GPS, and today was actually holding to with accuracy of below a meter. And it's got 4 engines that all of which can rotate in 360 degrees, and they're operating continuously to hold both the attitude and position in the ocean. In terms of increasing our head count, I think that's going to continue to grow, and our launch rate is going to continue to grow. We're expecting by maybe the third or fourth quarter that would be doing a launch every 2 to 3 weeks.
Stephen?
Thanks. Stephen Clark from Spaceflight Now. A couple of clarifications. I believe earlier you've talked about securing the rocket on the drone ship with welded shoes. I was wondering if that's still
that's what's happening.
That's still
We're
the
welding
plan?
it down. Yeah.
And
make sure it doesn't tip over. There's potentially some heavy winds coming in. So once the rocket's safe, the crew's going to go on there, and then we've got these steel shoes that we put over the landing feet and weld it to the deck.
And one more clarification: is it still coming into Port Canaveral? Is that the plan?
Actually, I'm not certain about that. I think that certainly is where it will ultimately be. I'm not sure if that is the initial destination.
Okay.
All right, let's come back over here on this side of the room. Right here. Right here.
Okay. Sawyer Rosenstein with Talking Space. Kind of going along with that, can you talk a little bit about the process of exactly how it gets, to that drone ship, how it stays on that drone ship, and then the process of what exactly happens from now that it's on until it gets back into port?
Sure. We're a little bit like the dog that caught the bus, So what do we do now? But the plan is to bring it into port.